Hi students, in this class we shall be discussing some important questions of exercise 5.1. So let us start with the 17th question. So here find the relationship between a and b so that the function f defined by f of x equal to ax plus 1 if x is less than or equal to 3 and bx plus 3 if x is greater than 3 is continuous at x equal to 3. Here it is given that the function f is continuous at x equal to 3. Here it is given that the function is continuous at x equal to 3 and we need to find out the values of a and b. Okay. So what does it mean by the function being continuous? It means that the left hand limit and the right hand limit are equal to the value of f of 3. Okay. So let us check this. So f is continuous. F is continuous at x equal to 3. This is given to you. Okay, given to you. It means that limit x tends to 3 from the left, f of x should be equal to limit x tends to 3 from the right, f of x, which is again equal to the value of the function at x equal to 3. Fine. Now let us find each one of them. So that is limit x tends to 3, f of x will be equal to limit of x tends to 3 minus, what is f of x? F of x in that case will be equal to ax plus 1, right? It is equal to ax plus 1. Okay. Now what is limit x tends to 3 plus, that is from the positive side, f of x, that is this one, bx plus 3. Okay, so limit x tends to 3 plus from the positive side x is defined as bx plus 3. So we have bx plus 3. And what is the value of the function at x equal to 3? It is defined from this case. So we have ax plus 1. When you put x equal to 3, we have 3a plus 1. So we have 3a plus 1, correct? So therefore we shall find the value of a and find the value of b from these equations. Okay, for simplifying the first part will be when you put x equal to 3, what you get? It is 3a plus 1 is equal to, this is again 3b plus 3, okay, and that is equal to 3a plus 1, that is equal to 3a plus 1. Clear? Now let us take the first two equations. Okay, we need to find the relationship between a and b. Okay, so this is the relationship between a and b. Okay, so we have 3a plus 1 equal to 3b plus 3. So it can be written as 3a minus 3b is equal to 3 minus 1, that is equal to 2. Okay, 3a minus 3b equal to 2 is the relationship between a and b, or a minus b equal to 2 by 3, whichever way. This is the linear expression which represents the relationship between a and b. Now in the next question, question number 18, exercise 5.1, question number 18. For what value of lambda is the function defined by f of x equal to this continuous at x equal to 0? So it is given that if f is continuous at x equal to 0, what is the value of lambda? That is the question. F is continuous at x equal to 0, then f is continuous at x equal to 0, then lambda equal to question mark. That is your first question. Same way the second question is if f is continuous at x equal to 1, what is the value of lambda? That is okay. So we will take the first part, that is this. Let f be continuous at x equal to 0. So therefore we know that limit x tends to 0 from the left, f of x will be equal to limit x tends to 0 from the right, f of x, which will be equal to f of x at x equal to 0, f of 0. Okay, so let us try to find the left hand limit. Left hand limit will go like this, limit x tends to 0 from the left. What was f of x when x is less than 0? It is this, that is lambda into x square minus 2x. And for the right hand limit, the limit of x tends to 0 from the right, f of x is defined as 4x plus 1, and the value of f at 0 is given from the first part, and that is 0. When you put x equal to 0, the whole expression becomes 0. Okay. So, here also when you put x equal to 0, this becomes 0. 0 equal to 1 equal to 0. This is not possible. This is not possible. Okay. Not possible. So, there is no value of lambda for which x or the function could become continuous. So, therefore, f is not continuous for any value of lambda. F is not continuous at x equal to 0 for any value of lambda. Okay. Now, f of x is defined as 4x plus 1 near x equal to 1 for all values x greater than 0. Okay. Now, f of x is equal to 4x plus 1 for all x which is greater than 0. So, therefore, limit x tends to 1 f of x, okay, limit x tends to 1 f of x will be equal to 4 into 1 plus 1, okay, that is equal to 5, correct. And f of 1 also will be equal to, f of 1 will also be equal to 4 into 1 plus 1, and that is 5. So, here f is continuous at x equal to 1 for any value of lambda. Okay. Now, we shall move to the next question. So, these two parts are done. Okay. For any value of lambda, f is not continuous at x equal to 0. For any value of lambda, f will not be continuous at x equal to 0. Same way, here even if you put any value of lambda, x will remain continuous at x equal to 1. It is not dependent on lambda at all. Okay, question number 9. So that the function g of x defined as, here g of x is defined as x minus bracket of x. Okay, here bracket x, you know that it is the greatest integer less than or equal to the value of x. Okay, now let us check whether it is discontinuous at all integral points or not. So, let c be an integer. Let c be an integer. Okay, let c be an integer. Let c be any integer. Okay, so then what happens? Then what is the value of g? G of c. G of c will be equal to c, and since it is an integer, the value of the bracket of x will also be equal to c, and that will finally will give you 0. Okay. Now, limit x tends to c from the left means x is less than c. Then what is the limit of g of x? Again, here we can define it like this: limit x tends to c from the left. G of x is defined as x minus bracket of x, right? So, when x tends to c, this is equal to x tends to c minus, okay, from the left hand side, x will be x itself, that is c, and bracket of c is defined as the previous integer. Okay, so minus of c minus 1, which will give you c minus c, this which will give you minus of 1. Okay, and what about the limit? So, clearly it is not continuous here. Okay, the left hand limit is not equal to the value of the function. Here only you can say that they are not continuous. So, limit of x tends to c from the right. Okay, so g of x, what is that? Let us check. So, limit x tends to c from the right, the function is defined in the same way. Okay, if you do c minus bracket of c will be c. Okay, bracket of c will be equal to c. X tends to c from the right. C is an integer, x is greater than c. So that will be equal to 0. Here g is not continuous at c, and c was any integer, therefore g is not continuous at all integral points. That's it. Simple question. Next, question number 20. In question number 20, is the function defined by f of x equal to x square minus sin x plus 5 continuous at x equal to pi? The function is very simple. X square plus 5 is continuous and sin x is also continuous throughout R. Therefore, it should be continuous everywhere. But let us check. So, f of pi. Okay, f of pi equal to pi square minus sin pi plus 5, which will be equal to pi square plus 5. Now for the limit x tends to pi, f of x will be equal to the limit of x tends to pi, both from the left as well as the right. It is defined as x square minus sin of x plus 5. Okay, the same function, we put the same function, and what we get here is we get pi square minus sin pi plus 5. Okay, and we know that sin pi is 0, so pi square plus 5. Okay, so that is equal to pi square plus 5. Here we see that it is equal to f of pi. Therefore f is continuous at x equal to pi.